Okay, can you see the screen now? Okay, so let's see. Can you all see the screen? Okay, all right, okay, good. Okay, so let's see 3.3. Okay, 3.3 here, this one is dividing the polynomial, and we have a remainder and a factor theorem. All right, so we're gonna be able to use the long division to divide a polynomial. We will also be able to using the synthetic division, or sometimes we call it a short division, okay, to divide the polynomial. The good news is in college algebra, synthetic division will work, okay? So if you don't want to use the long division, which you don't have to, but if you continue to calculus, in my calculus class, all of them have to use the long division because synthetic, it doesn't work in calculus course anymore. All right, but the good thing is in college algebra, synthetic or short division always work. Okay, so I'm going to show you both way to do that, and you can choose any way you want. Okay, so the divide here is just trying to show you, how do you do the divide, right? And I'm gonna just show you one of the quick using the regular number, right? If I have a 120, like I said. Okay, let's give a quick example on how to do the long division in an old-fashioned way. Okay, so I have you can just write down, if I want to have a 138 divided by 4, for example, okay? All right, so I have a 138 divided by 4, right? And now using 3 times 4 to get a maximum number compared to 13. All right. So now 13, you do the subtraction, right? Subtraction 13 minus 12, you got 1, and then you bring this one down, bring the next digit down, right? If I have another digit here, like a 1. All right, so you bring this one down, you use the maximum number, 4 times 4, 16, you do the subtraction, and then you're going to have a 1 in here, okay? So you're going to 16 minus 18 minus 16 is 2, and then bring the 1 all the way down, and then using the maximum number 5. 4 times 5, you got 20, so you do the subtraction, right? Do the subtraction, you got a remainder here is 1, right? So that's how you do the long division in the algebra. Same thing, you can do this way for the expression in here. Instead of just number, we're gonna have a polynomial in both the divisor and the dividend here. Okay, so eventually you function here can write down using the divisor, multiply the quotient, and then plus the remainder. If remainder is 0, that means this one can divide evenly into the f, and then we call this q of x is a factor, right? So for example, if I have a like I said, 42 divided by 2. All right, so that's the easy one. And then I have a 2 times 2 is 4, right? And then this is 0. I bring the 2 down. And then using 1, 1 times 2 is 2. So my remainder is 0, right? So that way I can write down 42 just 2 times 21. So that means 2 is a factor of 42. All right, so this one in here follow the same principle. Okay, so if I have a 2x cubed minus 3x squared minus 11x plus 7, you want to divide by x minus 3. How do you do this one? Okay, so it was a lot of things. Let me see. Okay. Let me just go ahead delete this whole thing, and then we can do all this together. Okay. And then you can see the step on how this work. All right, so basically for the first one right here, right? This one right here, this one is x. Okay, and this one right here is 2, 3x cubed. The key thing here is match the first term only. Okay, you always trying to match the first term. So how can x become 2x cubed? How can x become 2x cubed? So if I want x to become 2x cubed, right, I will have to multiply 2x squared. So that's your first term. So if I multiply 2x squared, I will get a 2x cubed. Okay, so basically you're using 2x squared times x minus 3. All right, you can do that on the side if you need to. And 2x squared times x, that's 2x cubed minus 6x squared, right? And sometimes people say, why this become plus? All right, because remember that earlier you had to do the subtraction. Okay, so I multiply 2x squared with x. I got a 2x cubed minus 6x squared. Okay, but we have to subtract the whole thing. All right, so basically this have to minus. Remember the number, we also using minus, right? Minus the whole thing. So when you minus the whole thing, I need to use the parenthesis because this one got 2 items. So this will be minus 2, and then this negative. That's why this one become positive. Okay, since we match the first term, so the first term always cancel out. So these 2 will be canceled out, right? And then you're going to have a negative 3x squared plus 6x squared. So you're going to get a 3x squared in here. Okay? And then bring the next term down, which is minus 11x. All right? And remember, we always match the first term. So now my first term here becomes 3x squared, and I still have an x in here. So now my x will need to become 3x squared, right? Always match the first term only. So x, how can x become 3x squared? Well, I need to times 3x, okay? So that's why you have a plus 3x in here. So now this 3x will times x minus 3. All right, and then you can get it in here. This will be 3x squared minus 9x, right? 3x squared minus 9x. And remember, you have to do the subtraction. You have to do the subtraction, subtract the whole thing. So I usually like to use a parenthesis in here and then distribute this one in. This will be negative, this will be positive, and then these 2 cancel out, right? So we're going to have a negative 11x plus 9x. You're going to have a negative 2x, okay? And then same thing, bring the next term down in here. Now we're going to have an x need to become negative 2x, all right? Matching the first term. X will become negative 2x. So since I already have an x here, I just need to multiply the negative 2. Okay, so negative 2 times x minus 3, we will have a negative 2x plus 6. Negative 2x plus 6. And remember, you have to do the subtraction, subtract the entire parenthesis. So this will be positive, this will be negative, and then these 2 cancel out. So 7 minus 6, you got 1. So 1 is considered a remainder. Okay, so now this whole thing you can write down 2x cubed minus 3x squared minus 11x plus 7. We are equal to this whole thing. Equal to this one is the quotient. Okay, 2x squared plus 3x minus 2 is considered a quotient, and then plus the remainder. All right, remainder here you have to keep the denominator because this remainder is 1. All right. So that means x minus 3 is not a factor for this entire thing because remainder is not 0. All right, this is called a long division, which is it sounds easy, but there's a lot of detail in here. Every time you do the subtraction, make sure you have a parenthesis and then you distribute the negative in. Okay, so that's called a long division. And what is a short division? All right, short division we also call a synthetic. Okay, we also call a synthetic division. So this one you write down x minus c form. Okay, and if I have a x minus 3, my c here will be exactly 3. All right, so I'm gonna using the same question using a different way. So I'm gonna write down 3 on the side. Okay, and then we're gonna just write down the coefficient for each um, item here. So I will start with 2, and then this one will be negative 3, this one will be negative 11, and then last item here is 7. Okay, this is using the short or synthetic division. You only using the coefficient for each item. Okay, and if you have a missing item, like I said, if I'm missing the x term here, I will need to supply the 0. Okay, all right, so now the key thing here is just bring the false number down. You don't do anything with the false number, just copy it down. Okay, copy this false number down in here. Actually, I don't need a line in here. Okay, so I will bring the false one down in here, and then we start multiply. Okay, and then 3 times 2, 3 times 2, you're gonna get a what? 3 times 2, you're gonna get a 6. Okay, 3 times 2 equal to 6. And the good thing is this one is always using addition. All right, so look at it. Okay, let me drop a little bit of clear in here. Okay, all right. Okay, bring the 2 down. 3 times 2, you're gonna get a 6. Okay, and then 6 plus negative 3, you got 3. Okay, you don't do anything with the first one. All right, and then 3 times 3, you're gonna get a 9, and then you add a 9 here, 11, negative 11 plus 9, you got negative 2. 3 times negative 2, 3 times negative 2, you will get a negative 6, right? And then 7 plus negative 6, you got 1. So we put a bar right here. That means the last one here is the remainder. All right, the last one here is remainder. And then this whole thing is my quotient coefficient. So my q of x, which is my quotient, will be 2x what? Will be 1 degree lower than the dividend here. So this is start with cube. My quotient here will be start with square. All right, so this will be 2x squared plus 3x minus 2. Look at that. That's exactly this quotient here. 2x squared plus 3x minus 2. And it's done. And then my remainder here is 1. The 1, same remainder here. It is 1. Okay, so the synthetic division setup look a little bit challenging, but look at the calculation. It's really quick and easy. All right, pretty much one step, I already got a quotient. Okay, so one thing here is you do need to remember, just bring the first term down. Don't do anything. And then after that, you start multiply. Okay, multiply for each one. And the good thing is using the addition, so it's very straightforward. Okay, so sometimes we call this one is a short division or synthetic division. And since in Cardinal algebra, our divisor is always linear. Okay, like x minus 3 or x plus, if you have a divisor, it's x plus 1, right? And then you need to write down x minus c. So you see here should be negative 1. Okay, and then you're using the negative 1 to do the division. All right, I think this method actually is much easier, okay, and less mistake to make the long division. Okay, any questions? Questions? Alright, so that is the short and the long division in here. Okay, so this one is also asking you to using the synthetic division to do that, right? So look at this one right here. I will write down x plus 2. I need to using x minus c form. So you see here should be negative 2. Look at the x cancel out, right? So c2 equal to negative c, or c is negative 2. So now you have a negative 2 in here, and then this coefficient is 1, right? 1. You're missing the x squared term, so that's why you need to using the 0 for the x squared, and then the negative 7, negative 6. Okay, so that's the setup. And then bring the first one down. You don't do anything with the first one. Now you're gonna have a negative 2 times 1. You're gonna get a negative 2. And then using the addition, so that 0 plus this one still equal to this one, right? And then negative 2 times negative 2, you got a positive 4. Using the addition, negative 7 plus 4, you got negative 3. Negative 2 times negative 3, you got positive 6. So this remainder is 0. 0 means this one is a factor, right? So basically x cubed minus 7x minus 6, I can write down as my quotient x squared 1 degree lower than the cubic, and then minus 2x minus 3 times my quotient here is x plus 2. Look at that. All right. So look at this one right here. I can even factor this one, right? The first is a quadratic. I can factor this one is x minus 3 times x plus 1, okay? And then times x plus 2. Okay, look at that. I just factor all these cubic function into all linear term, all linear factor. Okay, so that is the division. The beauty of this division, we can actually find a factor for this polynomial. Okay, so this cubic, I will have 3 factors. Okay, and if you remember that earlier, these 3 factors, they are all power of 1, right? So that means they are all crossing at this point, crossing when x minus 3 equal to 0, this will be 3, and then this will be negative 1, negative 2, will be all crossing. So I can basically drop this one by hand already. Okay, if you combine to the previous together, this is the cubic coefficient is positive, so you're gonna have a 1 1/3 quadrant like that, right? And then you're gonna have a 1, 2, 3, and then you will have a negative 1, negative 2. These are all crossing because the power all are power. Okay, so and then the intercept here, this will be negative 6. Y-intercept here is negative 6 when x is 0, right? So this one will be look like something like that. Okay, sketching. All right, so this will be the sketch for this polynomial. Look at that. All right, so we have an entire sketching for this cubic function in here. We have a 3x intercept in here. They are all crossing, right? And then 1 y-intercept in here. Okay, so that is the synthetic division. We can find the factor very well. And another one is called the remainder theorem. Okay, so what is the remainder theorem? The remainder theorem here is my f of the c will equal to the remainder. All right, so look at the f of the c. So what does that mean in here? That means my c here is negative 2, right? So if I plug a f of the negative 2 into this whole thing, it should get the same remainder, which is 0. So we can go ahead and give this a quick check. Look at that, negative 2 cubed times 7 minus 6, right? This one will be negative a plus 14 minus 6. And this whole thing, it is equal to 0. All right. So that is considered a remainder theorem if we have this one earlier. Our f of 3 should be equal to 1. Okay, if you put the x equal to 3 in, it should be the remainder theorem. My c here, my f of the c here, my c here is 3. So if I put this 3 in for this whole thing, okay, this whole thing should equal to 1, equal to the remainder. All right, so you can go to do the calculation, but it should be equal to 1. All right, so that is considered the remainder theorem in here. Okay, the remainder theorem, f of the c, yeah, the remainder here is f, exactly equal to this one right here. If you go to do this calculation, f of the 4, f of the negative 4 equal to negative 105 is exactly the same as the remainder here. All right, any questions? So that is basically our section 3.3, okay? And let's see what is section 3.4. Zeros of the polynomial function, which we talk a little bit from the zero of the polynomial function, right? Use the linear factorization theorem to find a polynomial, which I kind of just said it a little bit here. Okay. How do we find a possible zero? We have one method here is called using P over Q, reduced to the lowest term, okay? And this is the possible factor in here. So what is P over Q here? P over Q actually is equal to a factor of A sub n over a factor of A sub 0. So the other way. This should be a factor of A sub 0 over the factor of A sub n. A sub 0 is the constant term, right? There's no x in here, constant term. And then the A sub n is the leading term coefficient, basically. It's the factor of the leading coefficient in here, okay? So let's see how we do this one right here. Look at that. My A sub n here should be equal to 4, okay? And my A sub 0 here is negative 3. All right, so what is my P over Q? Well, P over Q is a factor of A sub 0, which is negative 3, over the factor of A sub n, which is 4, right? So how many factors we can factor negative 3? All the negative 3, you only have a negative 1 and 3 or 1 and negative 3. Okay, so we usually just write down plus minus 1, plus minus 3, and then the factor of 4, you can have a 1 and 4, right? And then also negative 1, negative 4, or you have a 2 and 2, negative 2 and 2. Or you can just write down as plus 1, 2, and 4. Okay, and then we're gonna go to do everything need to divide by 1, right? Everything divided by this 1. All right, so everything divided by 1 still equal to itself. And do not repeat. If you have something the same, do not repeat, okay? And then everything divided by the second one, which is 1/2. And then, okay, so I have a 1, 3, and then everything divided by 2 will be 1/2. Everything divided by 2, 3 over 2. So you have 3 over 2 here, right? And then everything divided by 4. So 1 over 4, 3 over 4. That kind of thing, that way. All right, I think there's something in here. There's 1 over 4. Oh, okay, this one is just trying to put it in an ascending order, that way. All right, so that is the possible rational zeros, okay? That means if this one has any x-intercept, will be one of these. All right, and how do I know which one is the possible factor? The quick and easy way here is do the graphing. before you do all the division on every one of them, because this one is said now you're gonna go to do the division for every one of these, which is a long way. Look at it, a long way to go. Okay, so I don't recommend to do the division for all these 1, 2, 3, 4, 5, 6. 6 times 2 gonna be 12. 12 possible zeros, right? So I don't really recommend to do the zero division for all possible 12 of them. So my recommendation here is using the, okay, let me go ahead, do the graphing, okay? And then you can see the possible zeros in here. Well, sometimes the question might not ask you exactly say you have to find the linear factor. It just want to ask you what is the possible zeros, okay? These are the possible zeros, so you don't really have to write down anything in there, okay? And then the same thing as this one right here. This one, my a sub 0 is what? My a sub 0 will be -2. My a sub n here will be 1, right? This is 1. All right, so your possible zero here is called P over Q. All right, so that's 1, -2, you can only factor into 1 and 2, right? And 1 here, you can only factor 1, 1 times 1. All right, so everything divided by 1 still equal to itself. So basically, this one you have a 4 possible zero, 1, 2, -1, -2 possible zeros, okay? And I'm not, is that now you're using synthetic division to find a rational zero among the 4 possible rational zeros, but I'm not going to do all 4 of them. So we are using the graphing. That's the quick and easy way. All right, so I'm going to graph this one, okay, x cubed plus x squared. Oh, x cubed plus x squared, okay, and then minus 5x minus 2. All right, and then I'm going to do my graphing. So looks like I do have a 3 real intercept in here, right? So that's 1, 2. Looks like these 2 is possible zeros, and then looks like we have a -2 in here, and this one looks like a -1/2. Okay, and if you really want to, I can make sure go to second table. Make sure I double check this one right here. So look at that. When y is 2, yeah, well, when x is 2, y it is 0. Okay, and then we don't have a -1/2 in here, right? But it is, if I know this one right here for sure, okay, I know this one right here for sure, I can do a division just for c equal to 2, or for possible 2 in here, okay? So I can do this possible, this is 0. So this one will be 1, 1, -5, -2, pull the first one down. 2 times 1 is 2, and then do the addition, so that's 3, multiply 3 is 6, right? And then add them together is 1. 2 times 1 is 2, so remember it is 0. All right, so that means this whole thing, f of x, I can write down as x minus 2 times my quotient. My quotient here will be x squared plus 3x plus 1, right? Because this is cube, so I have a x squared. So that is the factoring in here, okay? Because this one asking you to do all 4 possible synthetic division, which you don't really have to. Now this one remainder is 4, this one remainder is 3. Those are not the factor, okay? So now you have to do all 4 of them, and finally find 2 here, remainder is 0, right? So I can eliminate all those 3 division if I have a graphing, and then I can factor this one right here. I can factor this really quick, okay? And how do you factor into the linear, which this is quadratic? You can use the quadratic equation, right? So if you want to factor this into linear, just set this whole thing equal to 0, okay? And then using x negative b plus minus b squared minus 4ac over 2a. All right, using the quadratic equation, you can solve this one right here. Sometimes, some of the question is not factorable after that, but you can use this one to solve, right? And then solve this one right here. You do have a two real solution, okay? This is two real solution. One is positive, one is negative. All right, so that is all your solution in here. And then we can see from the graph, yeah, we do have like a positive 2, and this one is not a negative 2. Okay, this is negative 2, negative 3. So this is probably 2 points, negative 2 point something. And then this one is not a 1/2, because it's very hard to estimate, right? When it's not an integer in here. But we do know this got a three real solutions in here. Okay, so that is how you can do the solution in here. Okay, there's a little bit property for the root of the polynomial. It said if a plus bi is a polynomial solution, the conjugate a minus bi is also the solution. Same thing as the real solution in here. Okay, so if you have a plus square root of b, is the like I said, if you have 1 plus square root of 2, is a solution. 1 minus the square root of 2 is also the solution. This is called a conjugate pair. Conjugate always appear in a pair. All right. So this is just continue to, the same thing, trying to find a real solution in here. Okay. All right, that is pretty much a quick overview for this section. How do you find the possible zeros? Okay, possible zeros for the polynomial. Any questions? Okay, next 3.5. Okay, so 3.5 is we want to be able to identify the vertical and the horizontal asymptote for the polynomial, basically. All right, so how do we find the vertical and horizontal asymptote? This is considered the rational function in here. Okay, the rational function. Rational function is different than the polynomial, right? Polynomial will be all like you don't have x in the denominator, all the power are integer. But rational function is a two polynomial divided by. Okay, so now domain come up again, right? Because we have this NO is undefined. If a number divided by a 0 is undefined, if a 0 divided by a number, that is okay. All right, so that is the domain again in here. How do you find the domain? Well, sometimes you also have to be able to factor, right? If you have a domain here, denominator is x minus 5 cannot be 0, so that means x cannot be equal to 5. Okay, so your domain here, you're gonna have to include 5. Okay, sometimes I saw some people in the previous test did not know how to write down the interval notation. Okay, unfortunately in this course in college algebra, a lot of time they all ask you to write the interval notation, so I'm gonna emphasize one more time, okay? Interval notation, you always using a small number on the left and then comment the large number on the right, okay? So this one, basically x cannot be equal to 5. So you're gonna going to the left or going to the right, okay? And going to the left here is from negative infinity up to 5, right? And then going to the greater than 5, this is greater than 5, or x is less than 5, okay? So greater than 5 not include 5, so you're using the parenthesis in here, okay? So on the first interval, 5 is the large number. On the second interval, 5 is the smaller number. So that's how you write down the x not equal to 5 interval, right? If you have x greater than 2, less than 5, now it will be just 2 and 5 that way, okay? But this one is a 2 open interval. All right, if you have x over x squared minus 5, now you're gonna, well, this should be 25 according to this one right here. All right, so if you have x squared minus 25, this x squared minus 25 cannot be 0, right? Denominator cannot be 0. So we usually make it to 0 first and then solve for x. X will be plus minus 5, right? And then if you go to drop a number down here, you have a negative 5, you have a positive 5. So this actually you have a, we usually say one straight line got cut by 2 points. You're gonna have 3 pieces, not just 2, but 3 pieces. So this to the left, in the middle, and then to the right. So you have interval 1, 2, and 3. Okay, a lot of time people miss the middle interval. So this is from negative infinity to negative 5, and then negative 5 to 5. Okay, and then from 5 to infinity. So you need to have 3 pieces, 3 intervals. Okay, if you look at this one right here, x squared plus 5, actually this is always greater than or equal to 5. Okay, when we talk the domain is in a real number system. Okay, so this one, if you make a x squared plus 25 equal to 0, you're gonna have an unreal solution. All right, unreal solution. And we know x squared is always greater than or equal to 0. So x squared plus 5 will always greater than or equal to 5. So that means this denominator never going to 0. All right, so that means this domain can be all real number. Domain is all real number. That's how you write down all real number in here. Okay. All right, and then we're gonna look at the vertical asymptote. Okay, so what does vertical asymptote mean in here? Vertical asymptote, that means when x approaches to a number, this y gonna be either going to positive or negative infinity in here. Okay, when x approaches to a number, y gonna be either going to positive or negative infinity. That's called, consider the vertical asymptote. How do we find them? We usually make a denominator equal to 0 and look at if they don't have a common factor with the numerator. That's the vertical asymptote. All right, so let's look at some of this one right here. Look at it. This one, x squared minus 1 in the denominator, I can factor into x plus 1 times x minus 1, right? If you have a squared minus b squared, that's your factorial. Okay, and x squared minus 1, you can think is x squared minus 1 squared because 1 is equal to 1 squared. Okay, we call this one is a tricky one. So you can factor into x plus 1 and x minus 1. And when there's no common factor with the numerator, right? So that means when x is equal to 1 or negative 1, this will be undefined. Okay, so this is considered a vertical asymptote. So negative 1 and 1, vertical asymptote. What does vertical asymptote mean? That means graph will never pass the vertical asymptote. Okay, so if I put this one in a calculator, I can tell that way. So All right, if I graph this one right here, you can see I got 3 pieces of the graph, right? So this is not a polynomial anymore because polynomial is only one piece, continuous and smooth graph. This one got 3 pieces, okay? So this is considered a rational function. This graph, actually, there's a vertical asymptote in here. There's a vertical asymptote in here. The graph would never graph the vertical asymptote because it's not part of the graph. Okay, the reason we put in a vertical asymptote is helping us graph that manually. All right, so if I put this one right here and then I copy down copy down this one. Okay, so I will be able to copy down this one right here. Okay, so like you pass the 0 point, 0 and 0, right? And this one also have a horizontal asymptote, which is y equal to 0. In here, horizontal asymptote. Okay, so we usually, when we do the graphing by hand or something, the vertical horizontal asymptote, we usually using the dotted line because it's not part of the graph. Okay, not part of the graph. So we're using the dotted line instead, that way. All right, so you can kind of sketch that way. Yeah, so this is the vertical asymptote, x equal to -1 and x equal to 1. Vertical asymptote is a line, so you must write down as an equation. You cannot just answer 1 or -1. You have to write down as an equation. X equal to 1, x equal to -1. Okay, that's the asymptote because it's a straight line. All right, horizontal asymptote. Let's see what is the definition of the horizontal asymptote. Horizontal asymptote definition is a little bit different than the vertical one. This is when x opposed to infinity, y gonna opposed to a fixed number. Okay, so look at it. When x opposed to infinity, y gonna be opposed to 0. So the horizontal asymptote here is y equal to 0, right? When x opposed to infinity, y gonna oppose to a fixed number, either this way, or that way, whatever way. Okay, so how do we find a horizontal asymptote? We usually just compare the degree of the numerator and the denominator, the degree of the numerator and the degree of the denominator. I like the second one in here. If they have a same degree, okay, if this numerator and denominator has the same degree, we just using y equal to the ratio of the coefficient, right? Look at the a sub n over b sub n. This is the ratio of the coefficient, okay? And then you can use this one to match the fourth one and the third one. What I mean in here, so you don't have to remember all these different scenarios. You only need to remember the second one. All right, and let me show you how this one works. You don't have to remember the rest of them. Okay, so this one you have a same degree. Okay, so you horizontal asymptote will be y equal to 9 over 3, or just 3. Okay, just 3 in here. And then next one right here. So this one I don't have a same degree. What do I do? We can go to match the same degree. We can have a 0x squared plus 9x. Look at that. And that way we have a same degree. So my y here will be using the same degree. You always look at the highest degree, right? This highest degree is 2, so I have to match the 2 here. So this will be 0 over 3. 0 over 3 is okay. It's equal to 0. So your horizontal asymptote here will be y equal to 0. Look at that. If you go to the match the same degree, it will be really easy. All right. And sometimes people say, how about if I have this way? If I have my h of x equal to 9x squared over 3x minus 2, something like that. Now my numerator degree is higher than the denominator. That is your case 3, right? And then same thing, I can go to match the 0x squared right here. Look at that. I match the highest degree. I can my denominator, I can just write down the 0 x squared. So my y here will be 9 over 0. So what does 9 over 0 mean? This is a known. This is undefined. Okay, undefined in here. So that means this one do not have a horizontal asymptote. So when you match the degree here, match it to the same degree here, and you cannot find the answer here, that means there's no horizontal asymptote. Okay, that's how you find you using the same degree to be able to match all the 3 different cases. All right, any questions? Okay, so if you look at this y equal to 1 over x, this one has a vertical, also horizontal asymptote. Okay, your vertical asymptote here is on x equal to 0. So that's the y-axis. So that's your vertical asymptote in here. There's a dot line in here. Okay, horizontal asymptote, you're gonna have 0x plus 1 over x, right? This f of x. I can write down, my numerator do not have an x, so I can write down the 0x plus 1. So y will be 0 over 1 or 0. So y equal to 0 is in here. That's your horizontal asymptote. All right, so you can go to match this way right here, very similar to this one. Okay, any questions? So that's how we graphing a rational function, okay? In order to graph the rational function, we can find the x-intercept, y-intercept, find a vertical and horizontal asymptote, and then we can find all of them in here, okay? So how do I graph this one right here? First, we can define the x-intercept, all right? You can determine the symmetry in here, but you don't really have to in this case. The symmetry is even or up function, right? If you have a f of a negative x equal to f of the x, this is the y-axis symmetry, which is an even function. If you have a f of a negative x equal to this one, this is an r function. This is a r function. This one is an even function, right? And this one is symmetric with the origin, okay? But since we allow you to use a calculator, so this fourth step will be usually is optional. But you do need to be able to find the x-intercept and the y-intercept, vertical and the horizontal asymptote for all these. All right. So x-intercept is on y equal to 0. All right. So what is y equal to 0? Only the numerator can be 0. Denominator cannot be 0. So x-intercept, y equal to 0. You can only have a numerator equal to 0. All right. So your x-intercept here will be 1, common 0. That's your x-intercept, right? And then find the y-intercept is x equal to 0. So you can put a replace the x by 0 in, and then it's 3 over 2. Okay, and then we also have a vertical asymptote, x minus 2 equal to 0 or x equal to 2. That's your vertical asymptote, right? Horizontal asymptote, y will be equal to 3 over 1 or 3, okay, because you have the same degree in here. So now I am pretty much be able to sketch this one or put it in a calculator. We have my vertical asymptote is x equal to 2, okay, that's the vertical asymptote. We have a horizontal asymptote, y equal to 3, so that's the horizontal asymptote, right? And then we also have a x-intercept here is 1 and 0, 1 and 0. And then we have a y-intercept here is 0 and that's right here. So I'm kind of assuming this is probably this kind of graph, okay? And then we can put this whole thing in a calculator. You can have a detailed calculation in here, all right? So yeah, that's exactly how you look at that. if you graph the function, that's how much it look like in here. Okay. One thing I want to talk is make sure if you don't have this kind of format, make sure you use the parentheses. Okay, because if you don't use the parentheses, your graph is gonna be very very different, or probably maybe that's the wrong one. Okay, so how do I graph this one? 3x minus 3 parentheses divided by anytime you have two items, you need to use the parentheses. Okay, and then we hit graph. That is how the graph would look like in a calculator, right? So we have horizontal asymptote, vertical asymptote right here. We have x-intercept, y-intercept right here. All right, any questions? Okay, there's another one you call the slant asymptote. Okay, so if you have a slant asymptote, that means you don't have a horizontal one, because slant asymptote happen exactly a numerator has 1 degree higher than the denominator. And then you will have to do the division for the slant asymptote. The good thing is you can do the synthetic division. Look at it. This one do not have a horizontal asymptote, but it does have a vertical. X minus 2 equal to 0 or x equal to 2, right? And then slant asymptote, because this degree is exactly 1 degree higher than the denominator. So if you do the synthetic division, coefficient C here is 2, and then coefficient here is 2, negative 5, and 7, right? And then you have a remainder is 5. So the quotient here, 2x minus 1, is the slant asymptote, all right? And then you have a y equal to the quotient, which is 2x minus 1. And then you can go to make it a graph. So this line here is a straight line, but it's not a vertical line, it's not a horizontal line, so we call it slant asymptote. Some of the book also call this one is an oblique asymptote. Okay. And then you go to do the graphing, so this graph will fit into this way in here. All right, so now we're giving you a quick review for this section 3.5. Okay, we have a little bit of last section here. Okay, so let's see the last section. The last section here is a little bit polynomial inequality. Okay. So polynomial inequality here, basically you consider numerator and denominator. Let me check the algebra. Let me check the syllabus to see if this section is required. Okay, 3.6. Yeah, 3.6 is still required, but we usually just have a very basic inequality. Okay. This inequality, that means you have f of x equal to p of x over q of x, right? And look at that. If I have a positive over positive, that is still positive, but so that is greater than 0, right? But if I have a positive divided by negative, that is negative, is less than 0. Or if I have a negative divided by positive, that is still negative, is still less than 0, right? If I have a negative over negative, that will become positive, so that's greater than 0. Okay, so what does that mean in here? That means we need to find a critical point. All right, we need to find a critical points. So what is the critical points here? We set the critical point, we set the f of x equal to 0, we call the boundary point. Okay, so critical point, boundary point is the same thing. All right, so look at this one right here. If I want to find this rational inequality, we usually want we don't want this one is equal to 1 or 2 or 3, so we want to make sure this side is 0. Okay, one side is 0. So how do I make one side is 0? That means I minus 1. Okay, this is minus 1, minus 1. So this 2x over x plus 1 minus 1 will be greater than or equal to 0. All right, and I will go to do the this common denominator, right? 1, I multiply the denominator here is x plus 1 times x plus 1. And then we do a little bit calculation. So that is the inequality you have, right? That's eventually the inequality you have. And then we're going to make a x minus 1 equal to 0. X will be 1. Make a x plus 1 equal to 0. X will be negative 1. So 1 and negative 1 is considered a critical point or boundary point. Okay? Yeah, we have a 2 boundary point here. 1 on negative 1. All right, 1 on negative 1. So we're going to have a 2 boundary point or 2 critical point. This is going to separate this whole thing into 3 intervals, right? 1, 2, 3 interval. Okay, interval 1, that's interval 1. That's interval 2, that's interval 3, from 1 to infinity. And then we're going to go to use a testing point to check each interval to see if it's positive or negative, and that way we will know which interval is the solution. Okay, so we're gonna go to do a little bit testing point, like I say, in this interval you can test -2, right? And then plug a -2 into the equation. So now you have a answer here is greater than 3. Greater than 3, that is positive, right? So greater than 3 is greater than 0. All right. So we will find this whole thing. Is greater than 0. So that means this interval is the solution. So this interval is the solution. Okay. And then do the same thing for the -1 and 1. You choose 0 because 0 is within this interval. And f of the 0 is -1, which is less than 0. All right, -1 is less than 0. So that means this interval is not a solution set. And then you check the same thing for the third one. Okay, so you do the same thing for the third one. Let's see, do the same thing for the third one. Well, we're supposed to check the third one. Okay, so let's see where's the third one. Okay. All right, third one here is from 1 to infinity. Okay, 1 to infinity. You can choose 2, you can choose 3, or you can choose 10. Anything, any number in this interval will be all good. Okay. If you choose 3, f of the 3, of course, it's gonna be different, right? This is 3 minus 1 over 3 plus 1, so that's 2 over 4 or 1 over 2. Even these two numbers are different, but they are all positive. Okay, so positive, we want to find that is greater than 0. So yeah, this interval is the solution. Okay. So where's the final solution for this one right here? This final solution will be interval 1 and interval 3. This interval 2 is not a solution. All right, so we're going to write down the interval 1 using the interval 3. This is the solution. All right, so that is the inequality for this whole thing in here.